Welcome, Protege. In this project, we'll be controlling a pan tilt module with a 4-way joystick and an Arduino Uno. The pan tilt module consists of 2 servo motors, one for pan and one for tilt. For this project, you'll need a fuel can, Arduino Uno, 4-way joystick, a pan tilt module, a solderless breadboard, and 8-inch male-to-male jumper wires, 4 10 kilo ohm resistors, 30 gauge wire, preferably multiple colors, and a wire wrap tool, a soldering iron, solder, voltmeter, heat shrink and heat gun, male crimp pins and crimpers, and number 440 heat set inserts. First, we'll start making the housing for the 4-way joystick. You'll want to unscrew the 4 screws and take off the aluminum plate that came with the joystick. And we made a bigger plate out of 1/8 inch acrylic but kept the same mounting holes, and we mounted that onto the joystick. Next, we have to strip 8 2-foot to 3-foot long wire with the wire wrap tool to solder to each of the limit switch terminals on the joystick. Also, cut a 1/2 inch piece of heat shrink to place over each terminal. Solder on a piece of wire to each terminal, place a piece of heat shrink over the wire, and use a heat gun to shrink the tubing. Take a male crimp terminal and crimp one onto the other end of each wire, slide a piece of heat shrink over the terminal, and shrink it with a heat gun. And this is used so we can insert them into the solderless breadboard. And here's the finished wiring harness for the joystick. We used white wire for the inputs to each limit switch and different color wire for the output of each switch. We 3D printed the bottom housing for the joystick, and the step file for this is available for download on our website. The number 440 heat set inserts were placed in the top 4 holes so we can screw it to the top acrylic plate. Insert the wiring harness through the bottom hole and mount the top and bottom pieces together with 4 number 440 screws. Once that is complete, we can start wiring up the joystick. Place the 4 10 kilo ohm resistors on the breadboard with one lead connected to the ground rail. These will be used as pull-down resistors. Also, insert a male-to-male jumper wire into the node that the other resistor leads are connected to. These jumper wires will be inputs to the Uno. Insert the 4 white wires and 4 male-to-male jumper wires into the breadboard. These jumper wires will be outputs to the Uno. And when the joystick is moved forward, the limit switch that is closest to you is pressed. This may be confusing at first, but if you look at the inside of the housing, you'll notice that the limit switches are positioned at the bottom of the joystick shaft. So when the joystick is moved in a particular direction, the limit switch in the opposite direction gets pressed. This next part can be a little tricky, which consists of identifying which wire is connected to each limit switch. So we used a voltmeter to determine each wire. Once you have identified each one, you can insert each wire into the node that a 10 kilo ohm resistor is connected to. The last piece to interface in this project is the pan tilt module, which has 2 servo motors. Each servo motor has 3 wires, yellow for the PWM signal, red for +5 volts, and brown for ground. You want to secure the module to something. We mounted ours to a weather balloon chassis that we 3D printed. Use a male-to-male jumper to connect power and ground to power and ground rails on the breadboard, and connect the PWM signals to the Uno. The PWM signals for the pan and tilt motor get connected to pin 9 and 10 on the Uno respectively. Limit switches that correspond to down, up, right, and left get connected to pins 6, 7, 8, and 11 respectively. Connect the outputs to pins 2, 3, 4, and 5 on the Uno. And finally, connect the fuel cans, 5 volt and ground rails to the breadboard via the provided banana jack to test lead clip cables. Next we're going to go over the software. First thing we have to do is include the servo.h library, and that's the only library we need for this project. Next we have to declare two servo objects, one that we call servo 1 and the next one that we call servo 2. Next we declare 6 variables. 2 variables are used to store the position of each servo, and then we have 4 variables that are used to store the joystick movements. So we have up, down, left, and right. Next, in our void setup function, we have a for loop where we declare pins 2, 3, 4, and 5 as outputs, and these are connected to the input of the limit switch. Then we have another for loop to declare pins 6, 7, 8 as inputs, and then we declare pin 11 as an input here. Next we use the function servo.attach, and since we have objects servo 1 and servo 2, we do servo1.attach and pass in pin 9 since we have that connected to the PWM signal of the pan servo. And then we also have servo2.attach, and we pass in pin 10, which is connected to the PWM signal of the tan servo motor. Next we have our void loop function, and here we're constantly checking to see if our joy up, down, left, and right variables get set to 1. So to do that, we do digital reads on each of those pins, so 6, 7, 8, and 11. And then we have a series of if statements where we check to see if that was set to 1, meaning that the limit switch was pressed. So if we move the joystick in the upward position, that means that this variable joy up got set to 1. So we go inside of this if statement, and we have our variable pos2 that keeps track of the position of the servo motor. So we check to see if it's less than or equal to 180. If it's anything above that, then we won't move the motor in that particular direction. So if it's less than or equal to 180, we tilt the pan tilt module up, and then we pass that pos2 variable into servo2.write, which creates the PWM signal to drive the servo motor. And then we increment that variable by 1. And then in the other 3 if statements, we kind of have the same idea, but I'll cover another example. So here we check if joy down is equal to 1, meaning that the limit switch was pressed. And for this one, we check to see if variable pos2 is greater than or equal to 0, and if it is, then we can send the PWM signal to move the servo motor, and then we decrement pos2 by 1. And that's it for this tutorial. Thank you for watching. Please subscribe below or leave a question or comment.